Hey ManCave, this is Bob from DaBob's N-Scale ManCave, and today we're switching hats. That's right, we're going to build something. So what are we building? We're building a Free-moN module in N-Scale. What's a Free-moN module? Well, it's not a module that conforms to a set size, 2 foot by 4 foot that you see a lot of times. It's free. It can do angles, it can do straights, it can do all sorts of different things that you want to do. So you can always hook up with other people who made their Free-moN modules and hook up a huge layout and operate all weekend long playing with trains. So we're going to do a video series on how to build one of these from start to finish, and we're going to start with the design phase right now. So let's go. Why yes, we are building something, Bob. We are building this. But I'm going to tell you how I did it first. We're going to start with the design phase and how I came up with this concept, or how you can come up with your concepts of what you want to make as well. First thing you need to do is, what am I going to build? Well, that's always the best, always the most complicated question, is how am I going to build what I want to build? In this case, I decided I was going to make a trestle. And I wanted to make a trestle that was tall, with mountainous scenes and everything else. And so I had to come up with some sort of idea of what it was actually going to look like. So I used a few sources. I chose the internet, for one, because it has a plethora of information, like designs for trestle bents and how trestles go together. This one happens to be modeled after a Southern Pacific trestle design. Not perfect, but it's pretty darn close. And also I took what I had available and found some mountain scenery stuff that I had picked up from a long time ago that I couldn't use anywhere else. So I just made it fit. Yeah, make it fit. I'll show you that later on. But how was I going to do that in my vision? Well, I needed to figure out a number of things. Parameters. What are my standards? First of all, I need to know what the Free-moN standards are for building a module. Now, there's a link here for the Free-moN standards, and you can always look that up. I have that in the description. And the basic thing is you need a faceplate, because that's the most important piece, is the faceplate. How is it going to butt up against somebody else's faceplate? So the faceplates need to be pretty much identical in size and thickness and so forth, and material. The minimum height for that faceplate is 6 inches. So don't go any shorter, because things just don't flex and combine right if you don't have them the same size. You don't have a good mating surface, basically, right? So 6 inches tall, 3/4 inch plywood, which is of a high quality, like the maple, really high cabinetry plywood. Stuff that does not expand or contract with humidity and so forth. So you need something that's really good. The maple stuff is the highest end. I chose a poplar, which was actually a little bit cheaper to pay for the poplar. That also works pretty good. A real hardwood kind of plywood. So you need those pieces built, and you need a minimum width of your module at 12 inches. I chose 18 inches. A lot of people go 24, or somewhere in between 12 and 36. I've seen that, some wide modules. But that's typical. So try and keep it down to a manageable size for your transportation abilities. If you can't transport it, why build it, right? So in this case, I also went out to the internet looking for mountainous river kind of scenes and so forth, and I found one that I kind of liked to model that would kind of fit into a tighter curve on that other side, that 15-inch radius curve. And so I found something that kind of resembled what I wanted to look, and just modified it as I needed to kind of reflect that best I could. So how was I going to build the framework? That's the most important thing you're building, is the framework. The end pieces are obviously more important than what goes in the middle, But if you can't hold the thing together, you know, the middle is also important. So the whole skeletal process of this module is the most important thing that you're going to make, because otherwise it all falls apart. So in this case, I chose a 33-inch radius on a 24-inch radius track, and a roughly 15 and a half inches on the inside radius for that other side. So I had to plan that out. So I used what I had. And I have a couple design programs. One is SCARM, the other one's AnyRail, but I chose SCARM because it can do a 3D model of what I'm building with surfaces and track and all that other stuff to kind of give me a representation of what I had in my mind and how it was actually going to look. What kind of things were I going to have to cut, where I was going to cut, and so forth. And then I also used that to make my framework design. So I knew where all my pieces were going to go, all the little cuts I have to make for all the 6 sections of wood that go on either side of this, and what angles am I going to cut. And I got the math that I'm going to show you that as well. So all those little things come into play. How am I going to put it together? It's 14 inches tall. I had 19 inches of space in the back of my truck, so I wanted some leeway for some foam, padding underneath and above, and so that nothing bounces and hits the top of my tonneau cover. All those kind of things come into play when you're designing this. How am I going to transport? How is it going to connect? Is it going to connect to something else that is part of this module? You know, all these little factors go into what is the final product supposed to look like, and how do I get it there to show it off? Okay, how easy is it going to be to transport? Those things really come into play when you're designing. So let's get into some of those specifics in the design process that I'll show you that I was doing, and then we'll move on to part 2, which is going to be actually building the benchwork. Okay, today I'm making this framework. This is viewed from above. It is a 33-inch diameter radius, or actually radius on the outside, and about 15 and a half inch radius on the inside. But it's going to be 18 inches across here on both ends, and about 18 inches in between, or so, all the way through there, making this a corner module. I'm going to see how this works, but that's the plan. This is viewed from the top, so there's going to be a rise up here of about 14 inches, and in between the middle of that is going to be a trestle going across to both those ends. I'm starting with the ends and building the upper box and the lower box areas, and then probably start cutting in and making these curves and bracing. So I printed out a full-size circle with all the lines spread out how I want it, and my radiuses from the inner and the outer circle at 33 inches on the outside and about 15 and a half on the inside. And so I did this all in SCARM, figured it out, printed it out, and if you really want to know, I'll tell you later, but I wanted to know how big of pieces do I need to cut to fit in these areas here. And so if I measured them, they'd probably be pretty accurate, but in order to calculate how much angle you need to cut each board and how long each board needs to be on the outside of that circle, you take 360, which is the degrees of a circle, and you divide that by the number of pieces, 24, and then you divide that by 2. So 360 divided by 24 is 15, divide that by 2 and you get 7.5 degrees for each of these cuts. The length of the sides on the outside of that circle, because I'm putting the wood on the inside of the circle, you take the diameter, which is 66 inches, multiply that by pi, 3.141. That equals 207.306. You divide that by the number of sides you have, which is 24, and you get 8.64 inches per side. So that's going to be on the outside up here. And calculated for the inside diameter, that will be 4.12 inches. So that's what I'm going to have to start cutting to get this circle started. So let's get going. There you go, ManCavians. That's part one of how I'm building this Free-moN module, the design phase. Now, a lot of things go into it. I hope I covered everything. I'm not sure if I did, but use what you have available to you. Make a model of it. If it's just a rectangle, it's probably pretty easy not to do that, but plan ahead what your materials are, where things are going to go, and figure it out. The track plan is one of those most important pieces because that's what your trains are running on, but how you put everything underneath and mount it to is also equally important. But designing it, that is key, because everything else after that flows from your design. So if you like what you saw here today, give me a thumbs up. Leave a comment down below. Tell me what you liked, what you didn't like. Give me suggestions as well. I'm always learning. And if you want to get notified of future videos like this one, just ring that bell. And hey, if you haven't subscribed, subscribe. You'll like it. Till next time, ManCavians, happy model railroading. You stay off those tracks. Bye.